Today we're learning about multiple solution equations. We're going to start with a review and learn how to graph it on a buffer diagram. The first thing I'm going to do here is change all of my subtraction to addition. Next, I'm going to add all of my like terms on the right-hand side. Since these two numbers are different signs, I'm actually going to subtract them. Now I'm going to add 2.54 to both sides to get my x flat side. Now I'm going to add the opposite of 5.8x to both sides to get the constants by themselves. Next, I'm going to multiply by the reciprocal of negative 8.5 on both sides. This gives me the division problem, negative 9.341 divided by negative 8.5. Now I'm going to divide negative 9.341 divided by negative 8.5. Remember to move the decimal and line it up. And let's round this answer to the nearest tenth, since it's going to go on for a while. Which gives us x is approximately 1.1, or 1 and 1/10. So now we're going to talk about how to graph equations. Today we're going to talk about the difference between a closed circle and an open circle. And you'll use open circles when we learn about inequalities. We will only be using closed circles when we're going to talk about equations, and equations use closed circles. A closed circle, a circle is a dot that is filled in. And this means equal. It's the notation for equal. An open circle is the opposite. An open circle is a dot that's not filled in, and it means not equal to. So when we say that x is equal to 1.1, it's actually approximately equal to 1.1. If we say x is equal to 1.1, that means we can show where it falls on the number line by putting a closed circle on it. And the way that we're going to draw our number line so that we don't have to draw all the numbers that are on the number line, since there's an infinite number of numbers on the number line, is that we're going to just write down the answer and its opposite around a 0, and then put the closed circle on the correct answer. So we're going to put negative 1.1 on the left-hand side of 0, and we're going to put 1.1 on the right-hand side of 0. That's just to label those tick marks. So now we have 3 spaces for it, negative 1.10 and positive 1.1. Now we're going to draw a closed circle on positive 1.1 since that's our answer. The closed circle is basically a dot. It's a circle that's filled in completely. It's on the tick mark, on the number line. And it represents the fact that 1.1 is the solution. It is equal, x is equal to 1.1.
Yeah.
All right, so for this equation, to solve it, of course, we always start by changing subtraction to addition. Now we're going to add negative 13 to both sides, so that we're bringing our constants over to the right-hand side. Now we're going to add positive 2 to both sides so that we can bring our constants over to the left-hand side. And we end up with 0 equals negative 6. This could never be true. 0 is never equal to negative 6. It's something weird that's going on here. Now we look back up at the original equation, and we just switch around just a tiny bit, we might notice something. We can tell back in the very beginning that this is not true. Because t has to be the same thing. When you use the same variable, you're saying it's the same number. We don't know what number t is, but we know it's the same number. There's no way that some number plus 13 can equal the opposite of some number plus 13 could equal the opposite of that same number plus 7. That won't work. There's no way. So what this means is that there is no number that could make this a true statement. And the way you answer this is called the empty set, and there's a certain notation that you use. The notation is a circle with a forward slash through it. And this means empty set. You don't have to write the words empty set, but that's what it means. It means that there is no number, there's no rational number. And rational numbers include irrational and, I'm sorry, there's no real number. And real numbers include rational and irrational numbers. So there's no number that can make a set. The way you graph the empty set means that nothing can work. So what you do is you have your number line, and you just look at the line. Anything to the number line at all, and that is how you show that nothing works. Okay, so first thing I'm going to do is distribute here. highlight terms on the left-hand side because you always want to simplify before you start to solve. And I noticed on this step that the two sides are equal. And so what this means is that no matter what I put in the place of D, it will be equal. Let me solve it all the way to see what happens. Now you might have solved it differently. You solved it differently when you get 9 equals 9. It depends on how you solved it. If you added -7 to both sides first, you get 9 equals 9. If you added -9 to both sides first, you get D equals D. But in each case, you get a true statement. Just like on that first step. Towards the top, or one of the first steps, towards the top, where you see the two sides are equal to each other. Now let's say that D is equal to 1. We get a true statement, right? Because we end up with 9 plus 7 equals 9 plus 7, or 16 equals 16. So if D equals 1, we get a true statement. What if D equals -100? We end up with 9 plus -700 equals 9 plus -700. So we still end up with the two sides equaling each other. So what we're seeing here is no matter what number we put in the place of D, the two sides will equal each other. And what this means is that all real numbers are sufficient. Real numbers include rational and irrational numbers. So I could put pi, 3.141, blah, 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 infinite forever, in the place of D, and the two sides would still equal each other. Does that make sense? So the way that we answer this, the correct answer, is all real numbers, and we use a particular notation. That's the notation for all real numbers. And it means any number could make it a true statement. So the way we're going to put it on a number line is we're going to draw a line on the number line with arrows on both ends showing that it's infinite. Again, you don't need to label any numbers. Go ahead and put a 0 in the middle to that don't worry about labeling numbers. So today we've learned that when you solve an equation, if x equals something, or if your variable equals some number, you use a closed circle and put it on the number line, wherever that number is, to denote that that's the solution, that x equals that particular number. We've seen that when we solve an equation and nothing works, that's the empty set, and we graph it by having a blank number line, so we actually don't graph it. And we've seen that when we have an equation where the two sides are equal to each other, that means that an infinite number of numbers could make it a true statement, so all real numbers work. And the way we graph that is we have a number line and we put a line on the number line, directly on top of it, element, with arrows in both directions. So let's practice just a couple more examples of working with closed circles. So if I have an answer of x equals -2, where would I put that? Right, I would put a -2 on the side and a 2 on that side, and I put a closed circle on the -2. What about if I have x equals 6? Put a sticks on the right side. I would put a negative 6 on the left side and a 6 on the right side and close circle on my